63, geometry lesson 63. This is introduction to vectors. We're going to make a little bit more sense out of this when we move over to actually showing some things on graphs and looking at the work. But until we get to that point, the first thing that we want to do is we want to cover definitions. Okay, now I've taken the time to go through your book and pull out the definitions and take them out of the paragraphs that they're in and hopefully write them up here in a little bit more concise way. Okay, so a vector. Aaron, can you tell me what a vector is? A quantity that is both magnitude and direction. We're going to define magnitude here in a little bit. We're going to look at notation of vectors. We're going to look at, how do we represent these things? How can we add them? How can we subtract them? But it's a quantity that is both magnitude and direction. Let's see, Darian, can you define direction of a vector for me?
The orientation of the vector determined by the angle the vector makes with a horizontal line.
Okay, and that'll make more sense as we begin to see the visual component to it. The orientation of the vector determined by the angle the vector makes with a horizontal line. It's going to look a lot like a slope for the most part. Okay. It will have a beginning and an end. Okay, scalar. Caleb, can you tell me what a scalar is? Okay, a quantity that consists only of magnitude and has no given direction. These next 2 points, or next 2 definitions, are pretty self-explanatory. The initial point of a vector is what, Austin? Okay, so initial is where I'm starting from. Terminal point of a vector obviously would be what, Mariah? No, the terminal point of a vector? The end point. So initial is where it starts, terminal is where it ends. Okay. Magnitude of a vector. This is where, this is a little frustrating for me because they go ahead and they change the terminology here. Which seems somewhat unnecessary, but let's go ahead and read this. Miss IL, have I had you read yet? All right, why don't you tell me what the magnitude of a vector is?
The length of a vector, since magnitude is a length, absolute value bars are used to represent the magnitude of a vector because magnitude is a length. We can also refer to it in the same terms as distance.
Absolutely. Okay, so before I get very far, I'm going to show you what vector notation. If we're going to label a vector, let's say we're calling it vector R. Whenever we're used to labeling, let's say a line, we would label it like that, right? That means it has no beginning and no end. It will have a slope, but it would look like that, right? Okay, and I could, erase that end of it. What is this? The other was a line. What is this? What does that notation tell me? It's, all right, has a beginning but no end, therefore it is it's a what? Array, okay? Let's do that to that. Now what is this? It's a segment, has a beginning and an end, okay? Now if I want to label array, it looks like that. Looks like just 1/2 of that arrow. Okay? So that is how we label a vector. Okay? All right, let's continue on and look at some more definitions. Okay, the component of a vector, let's see, Jesus, can you tell me what the component of a vector is?
There's a horizontal vertical change from the initial point to the second point.
Okay, it will look similar to coordinate notation except with more pointed brackets rather than parentheses. So what we're saying is that it's going to look like this. Okay, except x isn't going to be a point and y is not a point, but x is the direction left to right and y is the direction up or down and how far. Okay. So I could have vector notation, let's call it 2, -3. This is going to tell me that I'm going to, from my initial point, I'm going to go 2 to the right, and from my initial point, I'm going to go 3 down. Okay? Sorry. All right, so vector notation is different, okay? If I had this, okay, 2, -3 is a coordinate. It is a single point, okay? This is a line. Okay, do we follow the difference there? A vector can be drawn anywhere on a coordinate plane, okay? It doesn't have to have a specific coordinate location for its initial point. Okay, and we'll see that later. Okay, it's a component of a vector. Opposite vectors. Matt, can you tell me about opposite vectors?
Vectors that have the same
Opposite direction. Okay, so if I had vector 2, -3, and I wanted an opposite vector to it, it would be the vector -2, +3. Okay, opposite means change of sign. Okay, we follow that so far. Okay, that should be fairly easy to determine there. That's just an example of opposite vectors. Okay, has the same magnitude, but opposite direction. So instead of going 2 to the right, I'm going to go 2 to the left. Instead of going 3 down, I'm going to go 3 up. Okay, which using Pythagorean theorem, we'll see that has the same distance. Okay, resultant vector. Let's see, Brady, can you tell me about resultant vectors?
Any two vectors can be added together by summing their components. The resultant vector is the result of the sum or difference of two given vectors.
So I can either add or subtract vectors. Okay, whenever, obviously, if I'm adding opposite vectors, but I'm only adding specific components. So I'm only adding, let's say, the x component and the y components. Okay, so 2 plus -2 is 0. Okay, -3 plus 3 is 0. Right, so I get a resultant vector of 0, 0. But I could take any other vectors and either add or subtract them. Okay, but I'm only going to add or subtract these, add or subtract those. So I'm not going to carry something from the y vectors over to the x side. Okay? All right. Let's see. Let's scroll on down here. And I think that's it. I think we're ready to kind of start looking at some questions here. So here we have a vector. We want to write this in component form. In order to write this in component form, I want to start from the initial point. What is my initial point here? Anybody tell me? What's the initial point? A. A is my initial point. And if I'm going to write my component form, am I going to go down first or over first? Down first or over? Okay, consider what is being represented in these locations. This is x. X represents my distance left to right. Okay? So that I don't end up switching or swapping, I want to go left or right first, then up or down. So if I'm going to go over, I'm going to go over 1, 2, 3, 4, 5. Is that a +5 or a -5 though? +5 because I'm going 5 to the right. Okay, so +5. All right, now I'm going down 1, 2, 3. Is that a +3 or a -3? -3. All right, so I should get a component form of 5, -3. Okay, so that's why I'm going to be specific there about I'm going to always go left or right first and then up or down. Okay, negatives will be based upon left and down. Positives are right and up. Okay. Now, number 2 says find a magnitude. If you go and you remember that definition for magnitude, what is magnitude the same as? May you remember? It's the same as distance. Okay? Even if I go back up here, okay, and if I wanted to find a distance from A to B, okay, I could look at this, but you'll notice that there are no coordinate locations for these things, right? There's no coordinate for A, there's no coordinate for B, correct? So can I use the distance formula here? No. Can I use the Pythagorean theorem here? Sure I can. Okay? Remember, we went To the right 5, we went down 3. Can I find the distance of AB? How? Equals AB squared, right? Or C squared. So I'd have 25 plus 9 is C squared. So 25 and 9 is 34. And so C, or my distance of AB, is the square root of 34. Because 34 is made up of 2 and 17, both of which are prime. So I can't break square root of 34 down any further. Okay, does that make sense? So if I know my component form, can I just use those absolute values in the Pythagorean theorem? Okay, so 6 squared plus 3 squared. Well, okay, so negative 3 squared. Okay, is it ultimately going to be the same thing? Sure. So I got 36 plus 9. And it would have been 9 whether it was positive 3 or negative 3, correct? Because we're talking about distance when we talk about magnitude, it's still an absolute value. Okay? So I got, 9 there, right? Okay? What's 36 and 9? 45. What do I need to do with 45? Square root it. Okay, square root it. But notice up here it's looking for the nearest tenth. So do I really need to simplify my radical, or could I do what with this? Plug it in a calculator. Okay, so let's break out our calculators. Okay, square root of 45 equals 6 point, we went to the nearest tenth, looks like 6.7. 6.7, this guy right here. Does any of this math seem too hard or too complicated up to this point? No? Okay, really a lot of it's just slope and Pythagorean theorem. Okay, let's come down here. Identify the equal vectors and the opposite vectors. So here's what we want to do with this. Let's take AB, okay, and let's find the component form of vector AB. Okay, so we're going to go from A to B. Am I going to go up or over first? Over. How far over do I go? 2. Okay, and I'm clearly going up. How far up am I going? 3. Okay, let's go to vector FG. Find out what that component form is. Okay, how far over am I going? 3. How far up am I going? 3. So vector 3, 3. Let's do CD. Okay, how far over am I going? 2. How far up am I going? 3. Okay, let's do, now is this IH or HI? IH. Why is it IH and not HI? Because of the initial point. The arrow tells me where I end at. Okay? So IH. Okay? Or International Harvester. Alright, so am I going left or right here? Left. How far? So I'm going to write what? -2. Am I going up or down? How far down? -3. Okay? And then my final one is JK. But seriously? Okay? How far to the right am I going? 4. How far up am I going? 6. Okay. So do I have any equal vectors here? Which two vectors are equal? A, B, and CD are equal. Okay? Do I have any opposite vectors? Okay? Both of these together are opposite of IH. Okay? Okay, equal and opposite. Okay? 2, 3 is opposite of -2, -3. has the same distance, has the opposite direction. Okay? 4. Now, this is my notation for magnitude because it has absolute value signs set around it. Okay, that tells me I'm looking for the distance from A to B here in question number 4. Okay, how do I need to go about doing that? How do I find the distance from A to B? Pythagorean theorem. What numbers am I going to use? 1, okay, because we're going to go up 1, and we're going to go over 6. My hypotenuse is this line right here, which is the line I'm looking for. Okay, we got c squared. 1 squared is 1. 6 squared is 36. 1 and 36 is 37. What do I do with 37? Square root it. Okay. And let's see what kind of answer they're looking for. They're actually just going to take this in simplified radical form. Is 37, will it break down? Can I divide 37 by anything? No. All right, so vector AB, okay, is equal to square root of 37. Okay. All right, I think 5 is our last question. So this is what I'm going to do with question number 5. I'm going to stop the recording here. I want you guys to work out number 5 on your own. I'm going to walk around and see if you get the right answers. It says add vectors A and B in the diagram below. So what you're going to have to do is you're going to have to write the component form of vector A and then find a component form of vector B and add the two together. Okay, and get a final vector for it. All right, so I'm going to stop this right here.